In south-central Oregon, far from major cities, famous monuments, and any landscape that might seem to hold a world secret, lie dry caves surrounded by dust, wind, and volcanic rock. At first glance, Paisley Caves doesn't appear to be the kind of place capable of changing the history of a continent. There are no carved walls, no royal tombs, no hidden temples, and no giant statues waiting to be discovered. There is only silence, dry earth, and layers of sediment accumulated over thousands of years. But precisely there, beneath the seemingly empty ground, one of the most inconvenient pieces of evidence for American archaeology appeared. Ancient biological remains, human coprolites, fossilized excrement that could be more than 14,000 years old. And that date was the real problem, because for decades, the most widely accepted version held that the first confirmed humans in America belonged to the Clovis culture, approximately 13,000 years ago. Then comes the question that turns the story into a mystery. What if one of the most important pieces of evidence about the first inhabitants of America wasn't a perfect spear, a complete skeleton, or a lost city, but something humble, fragile, and almost unimaginable as historical proof? What if a dry cave in Oregon preserved the sign of a human presence predating official history? The discovery wasn't spectacular because of its appearance, but because of its implications. If those remains were indeed in their correct place, if the dates were reliable, and if the human presence wasn't modern contamination, then someone had been in that region earlier than many models allowed. And that meant that the history taught for generations might be incomplete. To understand why Paisley Caves caused so much debate, one must first understand the weight of the Clovis theory. For much of the 20th century, many archaeologists accepted that the first inhabitants of the Americas arrived from Siberia, crossing Beringia, an ancient land bridge that connected Asia to Alaska during the last ice age. According to this explanation, when the great glaciers began to retreat, an ice-free corridor opened up between enormous ice sheets in North America, allowing groups of people to move south. This story seemed orderly, logical, and compelling. It had a clear route, an approximate date, and a recognizable culture, Clovis. The famous Clovis points were finely crafted stone tools with a groove at the base that allowed them to be attached to spearheads or shafts. They were elegant, efficient objects associated with hunting large Ice Age animals, such as mammoths. Their discovery at sites like Blackwater Draw, near Clovis, New Mexico, painted a powerful picture. Skilled hunters entering a nearly untouched continent, venturing into new lands, and leaving behind recognizable technology. For decades, this is why any site that appeared older than Clovis was met with extreme caution. Not necessarily because scientists refused to reconsider, but because such a bold claim required very strong evidence. A bone could have shifted, a tool could have fallen into a crevice, a sample could be contaminated, a date could be misinterpreted. Archaeology works with fragments, and when those fragments threaten to push back the clock of human history in the Americas, every detail must withstand intense scrutiny. Clovis was not just a simple theory. It was a comprehensive framework for explaining when, how, and from where the first Americans arrived. Simply put, for a long time Clovis was thought to mark the confirmed beginning of human presence in North America. But the Paisley Caves introduced a possibility that's hard to ignore: that humans were already in Oregon before the Clovis expansion. This doesn't mean Clovis is unimportant. Clovis remains a pivotal archaeological culture, with highly recognizable tools and an enormous role in the continent's history. What changes is the idea that Clovis was necessarily the first chapter. Paisley suggests that there may have been earlier chapters, more subtle, less visible, and harder to prove. The value of the site lies not only in the coprolites but in what those remains represent: a direct biological signal in an ancient context. To the average observer, it may seem strange that something so simple could change such a grand theory. But in archaeology, the most impressive objects don't always win. Sometimes a tiny fiber, a fragment of charcoal, a layer of sediment, or an organic sample can carry more weight than a sword or a tomb. What matters is not the object's appearance, but its context, its date, and its relationship to other evidence. That's why Paisley Caves became so important. It wasn't a story of treasure, but of time. It wasn't a story of gold, but of evidence. And if that evidence was correct, then the human arrival in America wasn't a simple, singular, and perfectly ordered journey, but an older, more complex, and still incomplete story. If you're interested in discoveries that seem small but can change major theories, subscribe to the channel, leave a like, and join us until the end, because this story is just beginning. What appeared in Paisley Caves didn't just challenge a date. It opened up a much deeper question about how many parts of our history remain buried, waiting to be understood. But the real problem wasn't finding the coprolites. The real problem was proving they weren't lying. Before we continue, comment. Do you think such a humble piece of evidence could weigh more than a stone tool? Like this post if you enjoy archaeological mysteries explained with real evidence. The Paisley Caves seemed unlikely to become a watershed moment in American archaeology. Located near Summer Lake in a dry region of Oregon, they are surrounded by ancient volcanic landscapes and remnants of environments that were very different thousands of years ago. Today, they may appear arid and silent, but during the end of the Ice Age, this region was part of a changing world, with lakes, animals, plants, and human groups moving through territories that bore no resemblance to the desert of today. This environmental shift is key because, as the climate became drier and water receded, the caves acted as natural preservation chambers. What would have decomposed or disappeared elsewhere could be protected there for thousands of years. And so, when archaeologists began to carefully excavate, the soil began to reveal small but unsettling clues. Plant remains, animal bones, worked fibers, signs of human occupation, and tools that did not fit the Clovis tradition emerged. But the most unsettling find was the coprolites. For many, the idea that ancient excrement could rewrite history seemed almost absurd. However, these remains could contain organic material that could be radiocarbon dated and, in some cases, biological markers like DNA. The tension grew because finding a carved stone, which can be debated based on its shape or location, is one thing, but finding a biological trace that could have been produced by a human body is quite another. Suddenly, Paisley was no longer just another cave. It was a kind of buried archive where each layer could contain a date, an activity, and a presence. The question was no longer whether the place was interesting. The question became much more dangerous. What if these layers were preserving a human occupation predating Clovis? When the samples were analyzed, the debate became inevitable. Some radiocarbon dates indicated ages of around 14,300 to 14,400 years before present. That is, approximately 1,000 years before the Clovis culture. That difference may seem small to someone looking at history from a distance, but for archaeology it was enormous. 1,000 years can change migration routes, climate models, theories of occupation, and the entire interpretation of how a continent was populated. Then came another, even more sensitive element: the analysis of ancient DNA. Some signals were interpreted as human and related to lineages associated with Native American populations. This made the evidence seem even stronger, but also more vulnerable to criticism. Because DNA is a powerful yet delicate molecule, can be contaminated, can move. It can be introduced by modern contact, by roots, by water, by insects, or by improper handling. That is why critics questioned whether the samples truly belonged to the ancient context or whether they had been contaminated from overlying layers. They also wondered whether some of the coprolites could have belonged to animals or whether the remains had been altered over time. These questions don't weaken science. They make it more rigorous. A discovery that threatens to rewrite the peopling of the Americas cannot be accepted simply because it is exciting. It has to withstand scrutiny, repetition, and revision. And that is what makes the Paisley case so fascinating. It wasn't a matter of believing or not believing, but of verifying. The evidence had to demonstrate that the coprolites were in the correct layer, that the dates were consistent, that the DNA was not a modern signal, and that other materials from the same context pointed in the same direction. The story then moved from the cave to the laboratory. There, the question was no longer just what had been found, but whether each piece of evidence could withstand scrutiny. In simple terms, Paisley Caves became important not because everyone immediately accepted the find, but because it forced better questions. In archaeology, finding something ancient isn't enough. You have to prove that the object or remnant is where it should be, that it wasn't moved by animals, water, or crevices, that it wasn't mixed with more recent materials, and that independent evidence tells the same story. That's why the debate was so intense. If the dates were wrong, Paisley could just be a case of mistaken identity. If the DNA was contaminated, the human evidence could be a false trail. If the layers were mixed, the chronology could collapse. But if the dates, the context, the organic remains, and the chemical signals all matched up, then the case became increasingly difficult to dismiss. The lesson here is important. Science doesn't advance solely through spectacular discoveries, but through evidence that withstands scrutiny. The critics weren't enemies of history. They were doing the work that science demands. And the researchers, by responding with further analysis, strengthened the site's value. This is why Paisley Caves should not be presented as a conspiracy against an official history, but rather as an example of how knowledge evolves. First, an anomaly appears. Then come the doubts. Then more evidence. And if the anomaly persists, the previous model must be adjusted. At that point, Paisley began to cease seeming like an isolated oddity and started to appear as a window into an America older than previously imagined. Then came a crucial question. If DNA could be disputed, was there a more robust test that could speak from within coprolites? Comment on which evidence you find most convincing. Ancient DNA, radiocarbon dating, stratigraphy, stone tools, or fecal chemistry. And if this case is surprising you, leave a like to support more scientifically based archaeological stories. After the initial criticism, the Paisley Caves case didn't remain frozen as a controversial claim. On the contrary, it was subjected to a verification offensive. Researchers knew that an ancient date wasn't enough and that a single genetic signal could be disputed for years. So the site had to undergo a much broader examination. Sediment layers, associated materials, radiocarbon dates, plant remains, tools, and the internal composition of coprolites were all reviewed. The idea was simple but demanding. If the layers were mixed, the dates should appear disordered. Young material might appear beneath older material, and the soil sequence would seem chaotic. But if the layers maintained a coherent chronology, then the mixing argument weakened. This part should feel like a forensic investigation. It's not about looking at a cave and jumping to conclusions, but about reconstructing a scene that occurred thousands of years ago from tiny fragments. Each layer is a page. Each sample is a word. Each date is a clue. And when those clues begin to fall into place, the story becomes harder to ignore. The tension lies in the fact that the site no longer depended on a single striking discovery. If there had only been a coprolite with an odd date, it would have been easier to dismiss it. If there had only been a tool out of place, it would have been easier to suspect displacement. But Paisley presented a combination of signs: organic remains, plant fibers, non-Clovis tools, coprolites, and ancient contexts. The question then shifted. How many coincidences are needed before we accept that perhaps we are not seeing a mistake, but a real story? One of the keys to strengthening the case was to seek evidence that didn't rely solely on DNA. That's why researchers paid attention to materials like plant fibers and other datable organic remains. If these materials appeared in the same context and offered a coherent chronology, they helped demonstrate that the layers weren't chaotic. But one of the most interesting pieces of evidence came from chemistry: fecal lipids. These compounds are molecules associated with digestion and can become trapped within coprolites. Their importance is enormous because, unlike DNA, they are less likely to move easily through the sediment. In other words, while DNA could raise doubts due to contamination, lipids offered another way to ask, what actually produced this coprolite? Was it human or animal? Was the biological signal inside the material, or had it come from outside? When different lines of analysis began to converge, Paisley's case gained strength. It was no longer a matter of a single fragile piece of evidence supporting a huge claim. It was a matter of convergence. The stratigraphy revealed ordered layers. Radiocarbon dating provided early dates. Plant fibers supported the integrity of the context. Coprolites offered biological material. Fecal chemistry helped assess origin. And the tools revealed a tradition distinct from Clovis. That combination is what makes the case so strong. In science, a single signal can be a mistake. But when different methods, with different weaknesses and different questions, point in the same direction, the picture changes. Paisley wasn't proving a simple story, but something deeper, that the Clovis model first couldn't explain all the available evidence. And that doesn't destroy archaeology. It forces it to grow. To put it simply, imagine you're investigating an old case and you only have one clue. That clue might be false, misinterpreted, or even just a random find. But if you find several distinct clues in consistent locations with similar dates and using different methods, then the accidental explanation becomes less convincing. That's what happened with Paisley Caves. The strength of the site wasn't in saying a coprolite changed history, but in showing that many small elements could form a large pattern. Radiocarbon dating, sediments, plant remains, biological signals, chemistry, and tools all pointed to very early human occupation. The simple conclusion is this: Paisley Caves didn't make Clovis disappear, but it did make Clovis no longer seem like the absolute beginning. Instead of a single, orderly entry point to the continent, a more complex picture began to emerge with possible earlier groups, different routes, and different technologies. This also teaches us something about how human knowledge works. Often, scientific models don't change because someone has a new idea, but because an accumulation of evidence forces us to look at things differently. At first, an anomaly seems unsettling. Then, if it's repeated and reinforced, it ceases to be an anomaly and becomes evidence. Paisley Caves represents precisely that moment, the instant when a small site begins to press against a vast theory. And when that pressure becomes too strong, the question is no longer whether an Oregon cave matters, but what it's telling us about the entire map of America. If humans were already there earlier than expected, then the inevitable question must be asked: where did they actually arrive? If Paisley Caves was correct, then the problem was no longer just one cave in Oregon. The problem was the entire map of the peopling of the Americas. For decades, the dominant explanation had been relatively straightforward: humans crossing from Siberia through Beringia, entering North America, and moving south along an ice-free corridor. But if there were people in Oregon more than 14,000 years ago, that route began to raise difficult questions. Was that corridor really open when it was needed? Was it viable for such early human groups? Could they have moved so quickly from the north to the interior and western regions? The timeline began to strain. And when one route ceases to comfortably explain the dates, another possibility begins to gain traction: the Pacific coast. According to this hypothesis, some human groups could have moved along the coastline, using marine resources, gradually advancing along beaches, bays, islands, and estuaries. This idea has particular strength because it explains why so much early evidence is missing. Many ancient Ice Age coastlines were submerged when sea levels rose. This means that part of the landscape where the first human groups may have moved is no longer visible. It may be underwater. This possibility opens up an even greater mystery. Perhaps there is no lack of evidence because these people never existed. Perhaps there is a lack of evidence because the landscape where they lived disappeared beneath the waves. And then Paisley becomes more than just an archaeological site. It becomes a terrestrial clue to a story that perhaps began on shores now lost. The lingering question is powerful. How many chapters of the peopling of the Americas remain hidden, not underground, but beneath the sea? The most balanced scientific response is not to say that Clovis didn't matter or that all the previous history was false. That would be too simplistic. Clovis remains a fundamental culture, recognizable by its fluted points, its wide distribution, and its association with large Ice Age animals. What Paisley Caves and other pre-Clovis sites suggest is that Clovis wasn't necessarily the first chapter of human presence in the Americas. It may have been a significant expansion, a highly visible and powerful technological tradition, but not the absolute beginning. Furthermore, at Paisley, tools associated with a different tradition, known as Western stemmed, have been found. These points lack the typical Clovis fluting. Their shape, base, and design reflect a different method of toolmaking. This detail is crucial because it indicates that the first human groups in the Americas may not have shared a single technology. There could have been distinct communities, adapted to different environments with their own routes and strategies. That makes the story much more interesting. Instead of imagining a single people entering through a single gateway and leaving behind a single culture, we can think of a more diverse, gradual, and complex process. Some groups may have advanced along inland routes. Others may have followed coastlines. Some developed a single technology. Others used different ways of hunting, gathering, and surviving. Paisley doesn't demonstrate a conspiracy or a dramatic version of everything we knew was a lie. He demonstrates something more serious and profound. A dominant theory may be useful for decades, but if new evidence emerges and withstands scrutiny, that theory must be expanded. Science doesn't lose its strength when it changes. On the contrary, it is strengthened. And in this case, the change doesn't erase Clovis. It places it within a larger story. In simple terms, the Paisley Caves teach us that human history doesn't always change because of grand discoveries. Sometimes it changes because of tiny remains, chemical signals, plant fibers, layers of sediment, and questions that seem uncomfortable at first. Paisley Caves isn't important because it has impressive monuments, but because it silently preserved evidence for thousands of years. That evidence forced a re-examination of a long-established idea, that Clovis was the confirmed beginning of human history in the Americas. Today, the picture seems more complex. The first Americans could have arrived earlier, moved along different routes, and developed diverse technologies. That makes the past less neat, but much more real. Nature rarely follows perfect patterns, and human migrations are almost never simple lines on a map. They are long, difficult processes, full of adaptation, loss, movement, and survival. That's why Paisley Caves has such narrative power, because it transforms something humble into a vast question. A forgotten remnant in a dry cave can force us to look again at the origin of a continent. A layer of soil can challenge decades of academic certainty. A small piece of evidence can reveal that the past was more expansive than we imagined. And perhaps that is the true lesson. History is not fully written. It is fragmented, buried, submerged, and waiting to be read in new ways. If a dry cave in Oregon could preserve a truth for more than 14,000 years, how many other clues are still waiting to change what we think we know? If this discovery made you see the history of the Americas in a different light, subscribe to the channel, turn on notifications, and leave a comment. Do you think there's still hidden evidence underground or underwater that could change history again? Share your opinion, like this video, and watch the next one, because another archaeological find could challenge everything we thought we knew about the past.